All right, so we're going to talk a little bit about sets and Venn diagrams because they can be a little confusing in what they mean and what sections you're talking about. And a piece that I am purposely leaving off to draw it in to just kind of bring emphasis to this is that these three pieces very well could be contained inside of our universal set, okay? So when we start talking about what are the outcomes or what pieces are we included, we want to make sure that we're paying attention to those parts and pieces. Now, whenever we deal with this, we always want to start with the innermost set of parentheses, in which case we're talking about the B intersection with C. B intersection with C is talking about, and I'm just going to add some labels to this to help us to have further discussions about this. It might be useful. Is let's call this 1, 2, 3, and 4, right? And that's just going to help us talk about that region a little bit more in depth, okay? So 2 and 4 are the intersection between B and C. 3 and 2 would be the intersection between A and C, and then 1 and 2 is the intersection between A and B, and then 2 would be the intersection of all three events, right? So when we look at the intersection of B and C, the intersection of B and C are going to be this items 2 and 4. Now this little C right here means the complement of. So that means that everything that is not that intersection. So in which case we're talking about 2 and 4 are the intersection. We want everything else. Everything else is what we're wanting. So everything else would be, how's the best way to do that? So let me grab a different color here, I'm sorry. So the best way to do that would be B, C, A, 3, and 1. Now, the piece that is most often overlooked is U. Okay, people think, oh, I've got everything listed. Why? What am I missing here? You're missing U, because 2 and 4 is the intersection of the B intersects C. Those are the two pieces of B intersects C. The complement is everything that's not 2 and 4, everything that is not in that intersection, which is the rest of B, the rest of A, or all of A rather, the rest of A that's not in that intersection piece, and the rest of C that's not in that intersection piece, and the rest of everything else that's not in that intersection, which is the rest of U. Now, this is where it may seem a little weird, is you're now saying, well, I'm going to do that union with A. Well, what's in A? A standard, right, if you will, 1, 2, and then 3. Now we have everything. So those pieces, 1, 2, 3, 4, 5, 6, 7 of those, did I count that right? So 1, 2, 3, 4, 5, 6, 7 of those are the resulting Venn diagram. So the only thing that's not included in that is just 4, right? So it's a really interesting way to just have that one piece excluded from this entire discussion. It's a bit of a sentence, I guess, but you do B intersects C, which is just 2 and 4. The complement of that is everything else, including U. And then you union that with A, which puts 2 back into the mix. All right? And I hope this helps your understanding of using Venn diagrams to have a better understanding of the intersection and unions of sets.